So here we are optimizing, right? So let's just, Lebuse, please go ahead and read the statement for us.
A metal box without a top is to be constructed from a square metal sheet with sides of 20 centimeters by cutting square pieces of equal size from the corner of the sheet and then folding up the sides. Calculate the dimensions of the box with the largest volume that can be constructed in this manner.
Okay, sir. Thank you so much, sir. As well as you, Mavilagazi, please go ahead and read it as well.
A metal box without a top is to be constructed from a square metal sheet with sides of 20 centimeters by cutting square pieces of equal size from the corners of the sheet and then folding up the sides. Calculate the dimensions of the box with the largest volume that can be constructed in this manner.
Okay, thank you so much, Elsie. Now it's time for a tutor to read. So here they say a metal box. Box is a keyword. And they say this box is without a top. Well, in this case, it doesn't really matter because the question is concerned with the volume. But if it had to do with the surface area, when the top is missing, it means one of the surfaces is missing. That's the significance of it. Nonetheless, a metal box is to be constructed from a square metal sheet. And this square has sides of 20 centimeters. But in order to construct this box, we are going to cut squares, well, square pieces that are having equal size from the corners of the metal sheet, and then folding up the sides in order to get our three-dimensional figure. Now they say calculate the dimensions, in other words, the length, the breadth, and the height of this box that has the largest volume. So the moment you say largest, smallest, least, most, farthest, shortest, nearest, then you understand that those are optimization type of questions. Now, in this case, we are maximizing the volume. That's the function with which we are working. And I hope you realize that the optimization questions are really different. But generally speaking, they're going to give you a situation whereby you'll be having two equations that you're going to be working with. And one equation will be used to express one variable in terms of another variable. But in this case, that's not the case at all. So I need you to pay special attention. This is a metal box, which is not a box anyway, a sheet. It's our metal sheet, which is a square. And going to this metal sheet, we know that the dimensions of this sheet are 20 centimeters by 20 centimeters. It's a square. So they just gave you the length of one of the sides. But of course, you know how to deal with the rest. Now I want you to realize this. From this metal piece, we are actually going to cut out squares. All right? Yes, we are going to cut out squares at the corners of this metal sheet. In other words, we still have our square metal sheet. Yes, that's true. But now we are going to go to the corners and we are actually going to remove the squares from the corners. However, we are careful and we want to ensure that all these squares that we are removing, they actually have the same size. That's what they said. They said equal pieces of those squares. Now then, after we have removed those squares, we are now going to fold this figure of ours in order to get our perfect box, because a box is a three-dimensional figure. But what are we folding anyway? That's a good question to ask. I want you to realize on this square that you see here, the shaded parts are now gone. That's very important. So that T shape that you are having there, you are now going to take this part and you fold it upwards so that it stands vertically. You take this part of the box, you fold it upwards, it stands vertically. You do the same for this part of the box. And you also do the same for the part of the, not really the box, but the metal sheet. That's what I wanted to say. Then what's going to happen after you now fold all those sides and put them together? Well, you are now going to have a box. And well, this is actually what my grade 5 teacher said to me in terms of drawing a box. And I still remember it today. Or rather to date, that's what I should have said. Well, I'm not saying I'm a good learner, but I'm saying she was a good teacher because she managed to instill it in me. And after so long, I still remember how to draw this. So yes, this is what we are now having. Now, this is what I want you to realize. What is that? Well, we don't know what is the length of the square that we are removing here. We don't know what's the length of each square. Well, since we don't know what's the length, we let it to be x. Now, what's the significance of the x that you are seeing here? Well, that's easy. How? Well, this is the significance of the x. It's now making a change to the length of the box itself, because the length of the box is now the one that you see here, the pink one. It means in order for you to find the length of the box, you're going to take the total length of the square and you have to subtract the x and come back again and subtract the x. Think of it. If we knew that we are cutting out squares that have a length of maybe 2, the length here is 2 and the length there is 2, but we know that the total length is 20. It would have been 20 minus 2 minus 2, which is just 20 minus 4, and that's going to be 16. But here we don't know what's the length of each square, but we know that the squares are equal to each other, so we let the length to be x. And that's actually what you need to write here, because your marker does not know what is x. So please tell him or her that you're going to allow the length of the small square piece. Okay, spelling is getting the better of me. Let the length of the small square pieces be x. Please do that, all right? Do things as if you're writing to someone who has no idea what is mathematics, and watch yourself get as many marks as possible. That's the first thing. So then, if the length of the small square piece is x, then what's the length of the box itself? Well, as we said, the length of the box will now be 20 minus 2x. That is how it works. Okay, fine. It's still a square even after cutting out those squares on the corners there. So it means this one as well is going to be 20 minus 2x, 20 minus 2x, and of course, 20 minus 2x even there. Okay, fine. The question here is asking us to maximize the volume. Find the dimensions for which the volume will be a maximum. The volume of the box, of course. Well, that's easy. In order for us to find the volume of any figure, we take the area of the base and we multiply this by the height, the perpendicular height, of course. Does anyone have an idea what is going to be the height of the box in this case? Any volunteer, please go ahead and tell us. Of course, if no one volunteers, then I'll have to ask a person. No volunteer. What do you think, Karabo? What is the height of this box?
I think it's going to be length.
You don't know. What about you, Vilagazi?
I also don't know. I don't understand what this question is saying, to be honest.
Level, sir.
Yeah, same, say, I don't know.
You don't know, sir. Okay. But do you all understand the base? All the pink parts are no. So all the pink parts that you see here, they're representing the base of this box. That's very important. Now, remember what they said. They said you're going to fold the sides. So that's very important. These are the sides that are being folded, the green parts. And when you fold them so that they stand vertically, then it means the height of this box is going to be X. You can literally do this at home and you'll see that it works. Like, for instance, you can take out a piece of paper from your page. In fact, what am I saying? You can take out a page from your book, just one page, and then you can use your ruler to go to the corners of that 4-page. You can use your ruler to draw squares of equal size, of course, on the corners of your page, and then literally use the scissor to cut them out. Then you will be left with something that you see here, which is the green thing. And then those parts that are, the green parts there, you can now fold them up and you'll see that it's going to give you a square. That's something you can see. But now the height, which is the part that you see here, is actually going to be your X here. Because think of it, this part is going to be the height, because when you fold it and it becomes vertical, then it becomes the height of your, the height of your box. So you don't need to begin by writing a formula. A formula is not really marked in many cases in mathematics. This is not physical sciences. But nevertheless, now that we understand how to find the volume, we take the area of a base, we multiply it by the height. Then what's going to be the base here? The base is a square. And what's the length of the base? The length of the base is 20 minus 2x. But then we know that the area of a square is side squared, which means I take one side and I square it. That's just what I'm going to do here. That's the area of the base. I still need to multiply this by the height. All right? So now I have managed to express my volume as a function of x, my volume in terms of x. Then now I can say, okay, fine, it's time for me to expand what is inside of the bracket. So when I go to my nice calculator and I square 20 here, I just get 400. Well, you need to use the FOIL method here, but I'm not going to show it. I'm just going to assume you know how to expand this. Then when you say 20 times 2, well, you just get 40. And 40 plus 40 is 80. But of course, it's negative 80x. And 2 squared is 4. So we get 4x squared for this one. Now we have managed to get our volume function. And that's why I'm saying in this case, we don't need two equations. We already have one equation, which is expressed in terms of one variable only. So it's very, very good. Yes, just to make sure my math is mathing right now. It should be exactly what it is there. Now that I have my volume function, I remember they said for which the volume is a maximum. And we know that every time we hear the word maximum, minimum, we understand that they're referring to the turning points. And at the turning points, that's where the derivative is equal to 0. So this means we need to differentiate the volume function. So what's the derivative going to be? Easy. According to the power rule, well, you know how it works. You say 4 by 3, you get a 12, you subtract 1. And then you say 2 by 80. Well, that should be 160. And then, of course, the derivative of 400x will just be 400. Then the next thing we need to do is to equate our derivative to 0. And since I need to solve this equation, well, when I try to divide throughout by 12, well, I'm actually not going to get a solid number, which means that I'm just going to have fractions, and I don't want fractions. So then I'm just going to use the quadratic formula in order to get the values of x here. I'm not going to show the quadratic formula, but you need to show it. Please do show it. It's marks there. Because this is difficult to factorize, it's much better when you're using the quadratic formula. Right. So I go in and say negative, my b is negative 160 there. And then I say negative 160 squared inside of the square root, minus 4 times a, which is 12, times c, which is 400, and everything is divided by 2a. Then I find that x is going to be 10 centimeters. Or what? Let's go to the other one. Or x is going to be 10 over 3 centimeters. Well, for the sake of logic, I'm not going to leave my answer as a fraction because this is a length. You can't say it's 10 over 3 centimeters. You don't find 10 over 3 on the ruler, but you can find 3.33 to 2 decimal places maybe. Now here we got two values of x. They're not wrong, but now we need to decide which one is going to give us the maximum volume. That's very important. And this is not surprising to get two values of x. Why? That's because your volume function is a cubic function. And you know that a cubic function has two turning points, so it's not surprising. We now need to find out which one is actually at the local maximum. You don't need to show us, but you can press it into your calculator and see. And then write the one that is giving us the maximum volume. What am I saying? I'm just going to go to my nice calculator and find the volume when x is 10 over 3. I'm going to press it as 10 over 3, not 3.33. Because it's not the final answer and it's really going to make a mess if we must substitute it elsewhere. So let's go. The original function is 4x cubed minus 80x squared plus 400x. And when I do, I get 160,000, in fact, 16,000 over 27, which is properly translated to 592.59. So this is the volume. Okay. Then we shift our focus, we go to x equals 10 and see what is going to be the y value when we substitute an x value of 10. Well, for this one, we find that the y value is going to be 3. Sorry, 0, 0, 0. Sorry about that. 0, 0. Yes, when you substitute x equals 10 into the volume function, we get the y value to be 0. Okay, fine. That's also not surprising. I'm not sure why it's not surprising, but yes, that's the value. No, it's the right one. So we get a 0, which means the 0 here is not giving us the maximum volume. So this means you need to cancel it out. Of course, you'll show it in your workings, but cancel it out. It's not the correct one. What is x though? X is actually the height of your volume. The question is looking for the dimensions. Now we know this is the right x to use. So how does it work henceforth? Well, now we need to find the length of each square. Okay, I shouldn't have said each, but the length of the base, that's what I wanted to say. Yes, the length of the base, which is this one, because it's a square, so it's the same thing. What do I mean it's the same thing? I mean, the lengths are the same in a square. So here you can conclude and say, therefore, the length of the box is going to be given by what? Easy. You'll say it's going to be 20 minus 2 into x. Please substitute it as 10 over 3 in order to get an accurate answer. So when you do the thing, you find that the length of the box will be 13.33 centimeters. And the height of the box, what is it going to be? Well, the height is just x. So the height here is simply going to be 3.33 centimeters. Those are the dimensions of the box for which the volume here will be a maximum. Yes, that's what we are saying. I'm not sure why it's 7 marks, but I think it should have been 5 at best. It wasn't that tough. So what about in this case? Well, in this case, they say it is given to us that h of x is defined as ax squared. It's a parabolic function, and the significance of them telling you that a is positive, that's because they're telling you that the function is facing up. That's what they're saying to you. All right? Now they say determine the value of a if it is given that the inverse at x equals 8 is equal to the derivative of h at x equals 4. Well, it's not really a tough question. This is where everything lies. It means you need to find the inverse of the function and also find the derivative of the function, then equate them together and get the value of a. That's all the question is saying. Okay? Well then, let's go ahead and do that. But firstly, we need to decide. Decide what? Well, I'm not sure what is it we are deciding. So let's go ahead. I believe the easiest thing we can do here is to find the derivative of h. A is just a constant, like 3x squared. The derivative here will be 6x. Similarly, the derivative of ax squared will just be 2ax, which means that the derivative at x equals 4, is simply going to be 2a times 4, which is simply going to be 8a. There's a mark for saying this, even if you didn't know the whole thing. But logic tells you to find these things first and then equate them together. It's not as bad as it looks, no? Now it's time to find the inverse. So here we are going to replace y with, or rather h of x with y. In other words, y equals ax squared. That's what I'm saying. Then I'm saving space, so I'm going to write next to this. I interchange my x and y so that x equals a y squared. Then I want to make y the subject of the formula, so I divide both sides by a, then I have y squared. But I'm just going to go ahead and find the square root on both sides, and I'm simply going to get something that looks like this. Plus or minus the square root of x over a, that is going to be the value of y. But now, the question here is, which one do we take? Do we take the positive one or do we take the negative one? That's really a good question. How do you answer that? Because they didn't tell you that you need to restrict the function to focus on positive values of x or to focus on negative values of x. They didn't tell you how to restrict the domain of the function here. So then how do you know which one is the right one? Well, that's easy. We know that if a is positive, the function is increasing. But now the derivative at x equals 4, where is that going to be? Well, it's definitely going to be on the right-hand side of the function there. That's where the tangent at x equals 4 will be. Which means that the function here is positive. That's what they're saying. And also this one is giving you a hint. Both of these values of x are positive. Do you see that? So it tells you that you're actually focusing in the first quadrant. In other words, this is how your parabolic function will be. And this is how the inverse of your parabolic function will be. The inverse at 8, at a positive x value of 8, the derivative at a positive x value of 4. So nothing can be clearer than that. We now understand that the inverse of h will have to be the square root of x over a. Then we find the inverse when x is 8. Well, this is just going to be the square root of 8 over a. Then we equate these two. Well, this one is going to be square root 8 over a, and this is 8a. And now you square on both sides. If you take 8, you square it, you get 64. You square a, you get a squared. The square root and the square will cancel out. And if you cross multiply, you get 64a cubed, which is equal to 8. And when you say 8 divided by 64, you're dividing both sides by 64. You get 1 over 8. And when you find the cube root on both sides, well, the cube root of 8 is 2, so the value of a will be 1/2. The plus or minus was very important how to decide on the one that you are taking. Both of these values of x are positive. That was a very important hint. Over and out.